Here are four more molecules that I want you to look at critically and decide whether they are acetals, hemiacetals, or neither, and then also identify the acetal carbon and the acetal bonds. If we look at this first molecule, we see as we have a carbon double bonded to an oxygen, and then that carbon is also attached to another oxygen. In this case, what we have is not an acetal. What we have is an ester. And we made esters in the ester lab a couple of weeks ago, and then we also did ester hydrolysis in the soap lab. We're going to understand this is not a hemiacetal or an acetal. There's no acetal bonds. We do have an ester linkage, and we're going to name this. We're going to name this based on this branch here, which is 2 carbons long. So we're going to call this ethyl. And then we look at the other portion of it, that if it was made by an alcohol and a carboxylic acid, the alcohol would be the branch, so ethyl. And then there's 1, 2, 3, 4 carbons, so this would be ethyl, and it's based on butane. However, it comes from butanoic acid, so the ic changes to 8, so it's butanoate. Ethyl butanoate is the ester right here. If we move on to this molecule here, what we see is that we have a carbon attached to an oxygen, attached to another carbon chain, attached to another oxygen. In this case, what we're looking at is an ether linkage. So this is a molecule that has 2 ethers in it. And we're not going to worry about naming this because this is beyond the scope of what we need to name. But this is ether linkage, not acetal or hemiacetal linkage. Now if we move down, we have a couple of cyclic molecules here. And what we want to do is we want to look to see, okay, here's a carbon attached to an oxygen that's attached to something else. But if we look at this carbon, it's only attached to other carbon chains. So from this perspective, we don't have an acetal or a hemiacetal. Here's our oxygen, and now we're going to move down to the other carbon that's attached. This carbon right here is attached to an OH, and it's also attached to an O that's attached to a carbon chain. So this O and this stuff over here can be considered the R group. So we have an O attached to a carbon chain. So what we have is a carbon attached to an OR attached to an OH, which means this is our acetal carbon. We have an acetal bond here, we have our other acetal bond, and this is a hemiacetal. The other molecule here, which is a simplified sugar molecule or glucose molecule, because we have 1, 2, 3, 4, 5, 6 carbons. And what we have here is going to be some sort of a cyclic molecule. If we look at all of the carbons on the left side of the molecule, so this carbon is attached to 1 oxygen and a carbon. This carbon is attached to 1 oxygen and a carbon. This attached to 1 oxygen and 2 carbons, etc. However, when we get to this carbon right here, this carbon is attached to an O that's attached to a carbon chain and another O that's attached to an H. So this molecule right here is very similar to this molecule right here in terms of whether or not it's an acetal or a hemiacetal. So we have an OR group and an OH group. So this is also a hemiacetal.